Today we're starting section 5 of chapter 4, and the title of this section is the graphs of sine and cosine. Okay? So for a moment I want you to go back to think of when you were in Algebra 1. The very first time you were introduced to parent functions. Little by little you were talked about like the linear function, and then the quadratic function, and then the cubic, etc., etc. And every single time you got introduced to one of these functions, they would teach you how to graph it. And every single time, the easiest way to do it is to create a table, plot points, and connect. Agreed? Well, that's what we're going to do today. Let's say that you have the function f of x equals sine of x. Okay? Just like you would in Algebra 1, we're going to create an xy table so that we can have points to plot in. Here's the tricky part because we're dealing with trig. Back in algebra, the easiest thing to do would be to plug 0, 1, 2, 3, right? Well, I would say, okay, with 0, we should be fine. Because if you plug in 0 there, what's the sine of 0? Agreed? But then if you try to plug in like 1, what is the sine of 1? And then you're going to be like, well, I have no idea. That's not on the unit circle. And then if you try to plug in 2, well, that's not on the unit circle. 3, 4. Do you see how none of those integers are going to be on the unit circle? So we're going to have to get a little smarter and kind of find values that are going to help us. In other words, could we use values that exist on the unit circle to help us out? Well, there's a whole bunch of values. We're going to have to be a little bit smarter and select the ones that are going to be the prettiest. What I mean by that are going to give you an integer as an answer. So I'll give you an example. Pi over 2 is the 90 degrees, right? What is the sine of pi over 2? It's 1. Can you guys think of another angle that's going to give me nice output? Okay, I heard pi. What's the sine of pi? Awesome. So keep going on your unit circle. What would be another or the next angle that's going to shoot out a pretty... Awesome. What's the sine of 3 pi over 2? Awesome. And we're going to complete a revolution and go all the way to 2 pi. You guys okay with that? 2 pi is 0. Okay, careful. Alright, I said I have a decent amount of points. Now I'm going to just plot them in. So here's what I'm going to do. Here's my xy axis, my coordinate plane. Here's my x, here's my y. Okay? Alright. Are you guys okay? I definitely don't want to go like by 1s or by 2s or by 3s, right? That's going to make it difficult. Are you guys okay if we go by pi over 2? On the x-axis, but are you guys okay that if in the y-axis I go by 1s? You get, like, you're gonna have that freedom. You get to set it up however you want to. You want to set it up in a way that is gonna be easy for you, right? So are you guys okay with me saying that? How about every 2 spaces is 1? Cool? It doesn't matter what you have. Okay. Let's plot the points. So I'm gonna use red. So 0, 0. Pi over 2, 1. Pi 0. 3 pi over 2, negative 1. 2 pi 0. Now, at that point you're like, well, should I just go straight and then just straight and then straight? Well, not necessarily, because we've already talked about this function before. I introduced it to you guys before. Do you guys recall that it looks like a wave? It looks something like... So don't draw straight lines, make it somewhat curvy. So I'm going to say something like that. Agreed? Now, it's a function. Will it continue going after 2 pi? So I suggest you go a little bit further and then draw an arrow to let me know that it keeps going. Agreed? Okay. That's what the parent function of sine looks like. What would you say the domain of that function is? negative infinity to positive infinity. Agreed? What would you say the range of that function is? Negative 1 to 1, inclusive or non-inclusive? So brackets, right? Fantastic. Now I'm going to ask you a couple terms. Maybe you remember what it is. What does it mean to be a maximum? The highest point that your graph is reaching, agreed? By looking at what you have present right now, what is your highest point? What is your maximum? 1. So are you guys okay if I say pi 2 comma 1? That's my maximum point, right? That's this point right here. What would your minimum be? So 3 pi over 2 negative 1. You guys okay with that? Okay. At this point, you might be like, that's kind of irrelevant. It's going to come back here in just a second, okay? One last thing I want to ask you about this graph, and then we'll move on to cosine. Typically, when you talk about any graph, you want to know about the x-intercepts. So x-intercepts is the same thing as a 0, right? Where are your zeros? And where else? So could we say that x is equal to 0, pi, 2 pi? Is this going to have more than those? Remember when on that quiz I asked you and you were like, well, there's a whole bunch. I don't know what to say, right? Well, now you know that there's, first of all, there's an unlimited amount of zeros, correct? Does anyone notice a pattern? So what would you say the next 0 would be after 2 pi? And then? So could we then come up with a rule? How about we say that the zeros are located at n pi, where n is any integer? Do you guys agree? I can put in any integer in there and that would be a 0 for the parent function. Okay? So without having to check or graph, you can be 100% sure and tell me that 1000 pi would be a 0. Right? Without having to do any math on the parent function. Cool? Questions about the graph of sine before we move on to cosine? F of x equals cosine of x. Let's create an xy table. I don't know why I did that, but oh well. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Do you think those angles are going to be nice for cosine? Probably. What's the cosine of 0? 1. Oh, look at that. It kind of worked out. What's the cosine of pi over 2? 0. What's the cosine of pi? Cosine of 3 pi over 2? Cosine of 2 pi? Okay, now we're ready. Can I go by pi over 2's again? Awesome. Plot the points. So I'm going to use 0, 1. So I'm going to say that this is 1, by the way. 1, negative 1. So 0, 1. Pi over 2, 0. Pi, negative 1. 3 pi over 2, 0. 2 pi, 1. And again, I know that this could almost look like the absolute value if you just connect it like that, right? But remember, make it curvy, right? So I'm going to say maybe something like that. And this has got to turn and keep going in both directions, right? All right. Looking at that graph, what would you say the domain is? All real numbers, agreed? What's your range? Same as the first one, agreed? Negative 1 to 1. What is your maximum value? Still 1, right? But now I have two specific spots where that happens, right? at 0, 1, and 2 pi, comma 1, right? Where's your minimum value at? Pi negative 1. Agreed? Lastly, let's talk about the zeros of that function. Sorry. Where would you say the zeros are located? At x equals what? Pi over 2, 3 pi over 2, continuation. Agreed? Can anyone take a guess, an educated guess, of where the next zero would be at? What'd you say? What do you guys think? This one's a little tougher to see. 5 pi over 2? Good. And then I'll tell you that the one after that is 7 pi over 2. And then the one after that is going to be 9 pi over 2. 11 pi over 2. 13 pi over 2. Can you help me come up with a rule then? N pi over 2, where n has to be what? Odd, but not just an odd number, but an odd integer. Okay? So then you can safely tell me that 99 pi over 2 is a 0 on the parent function of cosine. Cool? Questions over sine and cosine, the parent function. Are we okay with it? If I asked you to graph it, could you graph it? Could you find the zeros, the domain, everything that we found here? Yes? Awesome. Well, let's take it up a notch. What if I don't have the parent function anymore? What if I transform it? What if I do stretches, compressions, shift left, shift right, shift up, shift down? That's where we're going. You ready? Some of you are like, uh-oh, I don't remember those. So let's quickly review transformations from back in algebra. Okay? First of all, so this is just a review transformations. F of x equals a times bx plus or minus c plus or minus d. Okay? And technically this could be plus or minus, and technically this could also be plus or minus. Alright. We're going to go from left to right. What would this being negative, tell you? Reflection over what? Agreed? Okay. Which then takes me to the letter A. What does the letter A tell you, or what does it do? Vertical stretching or compressing. Agreed? Do you recall how to tell one versus the other? So how could you tell that something's a compression versus a stretch vertically? Okay, so if A is greater than 1, it's a stretch. And if A is less than 1, but greater than 0, it is a compression. And then some students ask me, well, what about all the negative numbers? Do they really come into play here? No, because the negative just tells you a reflection. So in reality, I can kind of improve this definition and call it the absolute value, because I don't really care about the negative. Agreed? The negative tells me about the reflection. That's all it tells me. It doesn't say anything about the stretch or the compression vertically. Cool? Alright. Then he takes me to this negative right here. What does that negative tell you? Reflection over y-axis. Okay? That negative right there. Alright? Which then takes me to letter B. What does B do for you? Horizontal, either stretch or compression. Okay? What happens when the absolute value of B is greater than 1? It's a compression. What happens when the absolute value of B is less than 1 but is greater than 0? It's a stretch. A horizontal stretch, right? Alright. And those typically were the ones that give you the most problem in Algebra 2. Yes? It's a negative that's in front of the B. Okay, there's a negative sign right here, sorry. Alright, which then takes us to the letter C. What does the letter C do? So, can I call it a horizontal shift? If it's positive, so if it's plus C, what does it do? So shifts to the left. If it's negative C, it goes to the right. Cool? And takes me to the very last one, the letter D. It's what? Some kind of vertical shift. If it's positive D, it goes up. If it's negative D, it goes down. And that's a review of transformations from back in Algebra 2. Okay, you typically learn that like, I don't know, in 2-3 weeks. I don't know how long it takes to go over those. Okay? We're going to take everything that you remember for the most part, and now we're going to apply it to trig. Okay? This might come in handy, so if you don't remember them very well, just keep it handy next to you. Okay? Alright, do we need a little bit more time on this? Yes? Okay, so I'll leave it up there. Alright, got it, guys? Yes? Okay, so I'm just going to put this to the side. I don't really need it right now, but I'm going to keep it handy because I'm going to need it. Alright, so here's what's going to happen. If you look at these functions that we graphed, you don't have to go back, you can just look at mine. If I was to actually continue drawing this, could you say that I don't really need to come up with more points? I could just copy exactly what I have here and keep going. So like if I was in a computer system, I could highlight this part, hit copy, and then move and then hit paste, and then hit paste over and over again until you don't have to draw this, until I get something that looks like and so on. So would you say that this is something that's just repeating itself over and over and over again? Right? Okay. When a graph has such behavior, there's a name for it. Functions that are, and I heard it somewhere, you're right, whatever you said, that are repetitive, like sine and cosine. So functions that are repetitive, like sine and cosine, are called periodic. A function that repeats itself like sine and cosine are called periodic. Now, the word periodic, you've heard it before. Let's not go to science because I know there's a periodic table, but let's not go there. Let's go in regular, everyday English language. If I tell you, hey, if I'm talking about a period of time, what am I talking about? It's like a chunk of time, right? if I'm talking about what period are you on in school, I'm talking about what specific time in your class you are, right? So for sine to be periodic, that means that I could break that graph into multiple chunks that are going to look exactly the same. Do you guys agree? Like I could break up into an unlimited amount of chunks, a limited amount of periods. Cool? So I'm going to give you a formal definition of a period. A period is how long it takes a function it begins to repeat itself. A period is how long it takes a function before it begins to repeat itself. That's in plain language, plain English language. Okay? There's a math definition, but I don't not really care about you knowing that. Okay? If you still don't understand that, let me give you a sketch. So let's pretend I'm talking about the function f of x equals sine of x. And I'm just drawing a sketch, okay? Nothing perfect. I know the sine of x starts here, and then he goes like that, and then he comes down, and then he comes back up. And then it starts repeating itself. Agreed? This is one period right here. From here to here, it's one period. Or you can just simply call it the period. Okay? That's the period. Question for you. If I go back to my functions, page 1, what's the period of sine? How long does it take before it starts repeating itself? Oh. You might want to go back and add that for your graph, please. The period is 2 pi. What about cosine? What's the period for cosine? 2 pi as well. Agreed? I start here, and then I go, and at this point I'm going to start repeating myself. It took 2 pi units. Okay? Alright, questions so far? So we've learned that sine and cosine are periodic, and we've learned that their periods are 2 pi. Cool? Ready for the transformations part of it? Let's do this. Vertical, stretch, and compressions. Okay, you told me that what variable tells you you're vertically stretching or compressing? So we have f of x equals a, bx, plus or minus c, plus or minus d. A is the responsible for us to tell us that we have a stretch or compression. Agreed? In trig, it's not that we're trying to make things more difficult, but we go away from saying stretch and compression. We changed the name. Okay? We called it amplitude. Amplitude is the new word that we're going to be using for trig when we're talking about a vertical stretch or compression. Okay? Here's the definition of amplitude. And then I want to see if you can kind of tell me what that means. Amplitude is half the distance between the maximum and the minimum of the function. Amplitude is half the distance between the maximum and the minimum of the function. And amplitude is very easy. You ready? Amplitude is equal to the absolute value of A. Where is A coming from? right there. It's the number that's all the way in front. Now you know how to find it, but let me make sure that you understand what actually amplitude is. Okay, so let me give you a sketch. So here's my y-axis, here's my x-axis. Let's pretend this time that I have a sketch of f of x equals cosine x, right? Cosine x starts at what? 0, 1, right? Okay, so I'm somewhere up here, and then I go somewhere down here, and then I go somewhere down here, and then right back up, right? Would you say that this is my maximum? And then would you say that this is my minimum? Right? And then there's a distance that goes from here to here. Correct? Well, the definition that it says that I don't want that distance. I want half of it. So the amplitude becomes from here to here. That's my amplitude. Half of the distance between the maximum and the minimum. The distance between the maximum and the minimum is this much. Half of it would be from here to here. That's your amplitude. Okay? That way you don't have to get lost with the whole way. This stretch, no way. This compress, no way. Which one was it again? Oh. No, it becomes a lot easier with trig. It's just amplitude. The amplitude is this much. Okay? Now we're ready to start practicing our sketching. Ready? Let's do this. So on a quiz or test, this is the question. Sketch the graph. F of x equals 1/2 cosine x. I am going to show you some tricks to make this very easy that avoid having to use tables and having to use algebra. I suggest that you pay attention because as these problems get harder, trying to use tables becomes nearly impossible. Okay? Here's what I'm going to do. Just by looking at the problem, the first thing I suggest you do is that you find your amplitude. What's your amplitude? Well, it's in the a value 1/2. The absolute value of 1/2 is. In other words, I'm going to be really honest with you. Amplitude, it's always a number that's all the way in front. That's it. But if it's negative, make sure that you make it positive. Okay? Amplitude is 1/2. What would you say your period is? Well, I'm dealing with cosine. How long was the period of cosine? Okay, here's what I'm going to do. You ready? Now that I have that information, that's all I need. And my sketch becomes super, super easy. Alright, here's my question to you. I know that you just saw the graph of cosine. You don't have it memorized yet. But where does it typically start? 0, is it a 0, 0 or 0, 1? That's when your amplitude is 1. But this time your amplitude is not 1. Your amplitude is... So instead of going to 0, 1, you're going to go to 0. Oh, awesome. So I'm going to say this is 1/2. I'm going to say that this is 1. Negative 1/2. Negative 1. So I'm going to plot a point right here. 0, 1/2. Agreed? How long is your period? 2 pi. So without having to really do anything, here's what I'm going to do. I'm just going to go randomly somewhere and I'm going to put 2 pi in there. Okay? Add 2 pi on the parent function of cosine. So what's the cosine of 2 pi? Say louder. 1. But the amplitude is not 1 anymore. It's 1/2. So you're going to be at 2 pi what? Okay. Agreed? Alright. Here's where my strategy begins. Are you guys ready? So I don't have to do any algebra. Well, some basic algebra. What's halfway between 0 and 2 pi? Okay. So I want you to find somewhere about the half point and call that pi. Okay? You got it? Now, very briefly, I'm going to show you the graph of cosine, the parent function. Here's your endpoints. Halfway between 0 and 2 pi is pi. Where are you at? Your lowest possible point. Agreed? You have to go up to your lowest possible point. In your case on this one, what would it be? Awesome. Question for you. What's between 0 and pi? So I would say maybe pi over 2 somewhere here. Look at the parent function, okay? You ready? Between 0 and pi is pi over 2. Where are you at? Where are you going to be at on this one? Awesome. What's between pi and 2 pi over 2 pi? 3 pi over 2. Where do you think you're going to be at? And you've successfully sketched the graph of 1/2 cosine x without really having to do any work. Could you have created a table for this? You sure could. And I can do that like in 30 seconds for this problem. You don't have to write it down. But technically this is what happened. If you use 0, pi over 2, pi, 3 pi over 2, 2 pi, then you got the points 1/2, 0, negative 1/2, 0, 1/2. And those are the exact same points that are there. Because if you plug in 0 there, cosine of 0 is 1 times 1/2, 1/2, etc. Cool? That wasn't that terrible creating a table. Agreed? You try this one and then we'll take a break. F of x equals to 3 sine of x. So try to sketch that out for me, please. Try to sketch that out and then come back and check your answer. Alright, let's talk about it real quickly. What was your amplitude, guys? Okay. What would you say your period is? Okay. What I would do is, I'm dealing with sine. I know that I'm always starting at 0, 0 with sine. How long is your period? 2 pi. So I'm going to go ahead and just randomly select 2 pi. At 2 pi, what's the sine of 2 pi? 0, right? So I'm going to plot a point there. Then the strategy is to ask yourself, what's halfway between 0 and 2 pi? Pi. Sine of pi is? Okay. What's halfway between 0 and pi? Okay, remember, this is where knowing your parent function helps. It goes up, then down. So that means that if it has to go up and it has an amplitude of 3, you are at the point pi over 2 comma 3. So then you're going to go up and down, and then what's between pi and 2 pi? And where do you think you're going to go over there? And it keeps going on that direction, and then it keeps going on that direction. Agreed? The amplitude is 3, the period is 2. Questions? Alright, let's take a little break. Let's talk about horizontal stretching and compression. Okay. You told me earlier while we were going over, reviewing over our transformations, that if you had f of x equals a times bx plus or minus c plus or minus d, what would tell you if you had a horizontal stretch or compression? The letter B, right? So B, this right here, told you if you had a stretch or compression, right? So we're going to keep that in mind. So now let's pretend I have the function f of x equals to cosine of 2x. Then looking at that, can you tell me what the amplitude of this problem would be? It's the number that's all the way in front, right? So it's a 1. Now, remember how with the other ones you were just automatically telling me that the period was 2 pi? I want you to leave this blank for the moment. We're going to find out if it really is 2 pi for this one. Okay? That's kind of a hint that it's probably going to change, right? So, here's what we're going to do. We're going to go back to making a table because this one's easy. Okay? Give me some nice angles. Can we use the same ones we were using before? The 0, pi over 2, pi, 3 pi over 2, and 2 pi? Yes? Okay. 2 times 0? Cosine of 0? Cosine of 0? 1. Agreed? Okay. This time I'm actually going to have to write this down. So cosine of 2 times pi over 2. Agreed? I'm going to simplify this out. That becomes cosine of what? Pi. What's the cosine of pi? Unit circle. What's the cosine of pi? Cosine. -1. Good. Alright, now this time I'm going to say cosine 2 instead of x, I'm going to put in a pi. Agreed? So what's the cosine of 2 pi? 1. Alright, this gets interesting. So now I have cosine of 2 times 3 pi over 2 equals to cosine of 3 pi. What's the cosine of 3 pi? Okay. Cosine of 2 times 2 pi equals to cosine of 4 pi, which equals to... Okay, interesting. I have enough points though. Agreed? Alright, so this time I'm going to go ahead and label it. So pi over 2, pi, 3 pi over 2, 2 pi. And I'm going to plot the points. So I'm at 0, 1. So I'm going to say this is 1 and this is -1. 0, 1. Pi over 2, -1. Pi 1. 3 pi over 2, -1. 2 pi 1. And at this point you're like, well, unless you really know your parent function, you might be a little puzzled. Like, wait, how is this going to look? Well, remember, all these graphs have this wave behavior, correct? So somehow, some way, I need to do this. That wave behavior. Agreed? Something like that. You guys okay with that? Here's my question to you. That looks like it's the same thing repeated twice, right? So then, you know that a period is before it starts repeating, correct? So how long would you tell me that the period is? So from here to here, that's your period, and it equal to pi. Agreed? So now you know that when you have some kind of horizontal stretch or compression, it's going to do what to your period? Change it. You doesn't have to shorten it, it could also elongate it. So the way you're going to be able to figure this out beforehand, there's a formula. You ready? The period equals to the normal period. So what I mean by that is the period of the parent function divided by b. Where in the world am I getting that b from? Remember this? That's where it's coming from. Okay? So now, I know we've already done the problem for that one. But if we go back and find the period using the formula, period equals, what's the normal period of a cosine function? Divided by what's the b value in this function? Does that match that? Cool? You're going to need to know this one right here. we have 3 more graphs. I'm going to let you try one of them, and then I'll do the other 2 with you because they get difficult, okay? So I want you with your partner to try the following. F of x equals 4 cosine of 4x. I suggest that you find your amplitude and your period before you start sketching, okay? So, just together so that we're all on the same page. What is your amplitude? Okay. And your period, you're going to find it by taking, what's the normal period of cosine? Divided by what? Which becomes pi over 2. You have your amplitude, you have your period. You should be able to come up with a sketch without really having to do much math, right? If you use the trick that I show you, this becomes very simple. So try it out with your partner, and then we'll go over it together. Alright, so here's what I would have done first. So here's my XY axis. Okay. It's cosine, and you're typically at 0, 1, but because your amplitude is 4, you're going to be where? 0, 4, right? So I'm going to say that this is 4. I'm going to say that this is negative 4, right? Then I'm going to use the information that I have here. So how long is your period? So pi over 2. So I'm just going to randomly just go somewhere and call this pi over 2. With cosine, you start at 1, right? And you're also going to end at 1, correct? But in this case, because your amplitude is 4, then you're going to be at pi over 2, comma 4. Agreed? Now, halfway between here, there's going to be a point. Do we know what that point is? It's pi over 4. And because it's cosine, I need to go to my lowest possible value, which in this case would be negative 4. Halfway between 0 and pi over 4, there's a value, pi over 8. And at pi over 8, I need to be at 0. Halfway between pi over 4 and pi over 2, there's a value, 3 pi over 8. And I'm at 0. And if I sketch this, it should look something like that. Question. Is this on the unit circle? Do you see how creating a table for this is going to require a calculator? Do you see why I keep encouraging you not to try to use tables for this? Especially as we start doing transformations to them. Okay? I feel like my strategy works as long as you know the parent function. Okay? Questions on this one before we move on to the hardest one we're going to try today? Alright. So far today, all we've done was stretch or compress vertically or horizontally. We haven't done up, down, left, right. And typically in algebra you are like, well, those were the easy ones, right? With trig, they're actually the opposite. They're the more difficult ones. Okay? So I need you to really, really pay attention to this next example, since we're only doing one example together. Okay? Pretend you have f of x equals 6 sine of pi over 4x plus pi over 2. I'm going to put this in parentheses. Minus 3. Okay? Alright. So write down that problem, and then I'm going to need your help. You are going to have to rewrite this, otherwise you're going to get this wrong. I repeat, you are going to have to rewrite this, otherwise you're going to get this wrong. I want to see if you remember this. I need to factor out. So if I do that, then that means I have pi over 4 times something minus 3, right? If I factor out that pi over 4, what can I multiply it by so I can get pi over 4x? Cool? If I factor out pi over 4, what can I multiply pi over 4 by to get pi over 2? This is where it gets tricky, so let me show you. I would not mind if you went to the side and I was like, hold on. So this is going to be pi over 4, right, times something. I don't know what that something is, so can I call it x? You guys okay? That needs to give me pi over 2. Agreed? Well, I have multiplication and I need to get x alone, so how do I undo multiplication? Okay. X equals, are you guys with me? Fraction divided by fraction. Top stays the same, division turns 2, and bottom pi's go away. 4 divided by 2 is, because think about it, what's 2 times pi? Well, 2 pi over 4, and doesn't that reduce to be pi over 2? Yes? This is an essential step. There's a question just like this on the quiz. There's a question just like this on the test. Okay? You have to factor out the 4. Have to factor out the, in this case was pi over 4. Okay? Here's the reason why. If you didn't do that step, then you would have told me that this was going to move left pi over 2 units. Agreed? When in reality, it moved left 2 units. Cool? Alright. Now that we rewrote it, what I suggest you do first is identify all your transformations. Start with what is it? Good. What's your period? Well, what's the typical period of a sine function? What's the b value this time? Pi over 4. This gets interesting. So then this means that, can I rewrite 2 pi as 2 pi over 1? And then switch to multiplication and flip the other one to 4 over pi? Agreed? Pi's go away. 4 times 2 is, so your period is 8. Interesting. Okay? We know the amplification. We know the period. What is that 2 going to do? Left 2, down 3. Agreed? Okay. I want you to write that down, and then I want you to put your pencil down and listen to what I'm going to say and watch what I'm going to do. Okay? Because these are the trickiest ones to graph, but I'm going to show you another trick. I am going to graph this and ignore this. Pretend that was never there. Okay? And I'm going to use colors in this. So I'm going to use red for this, okay? So here's what I'm going to do. I'm going to go and create myself an XY axis. I'm making this kind of big because I'm look at the amp is 6, right? Making this kind of big. Here's what I'm going to do. The original function was sine, right? And your period is 8. So what I'm going to do is, I'm going to write down the number 8 just randomly here. Okay, 8. Cool? It's sine. You always start at 0, 0. Agreed? So that means I'm going to plug a point right there. And you always end at the same spot. Agreed? Question to you. What's halfway between 0 and 8? So that's my strategy one more time, right? So I'm using that strategy that I've been using. And I'm going to plot a point there. Agreed? Because it's sine. There's a 0 there. What's halfway between 0 and 4? Remember how sine goes up, then goes down? It's 6, right? So that means I'm going to have the point 2, 6. I'm going to say this is 6, just for our purposes. So then 2, 6. Agreed? And then between 4 and 8, I have the point And where do you think I'm going to be? So 2, 4, 6. So 6. Okay. Here's why I really wanted you to have two colors. I'm going to do this one as dotted because this one's not my answer. This one's here to help me figure something out. That's not my answer. That's why I did it dotted. Now, you're going to go back and remember that information that you ignored? Apply it to this graph that you came up with. The reason why it becomes easy is because now you have points. For example, it says, move left 2, move down 3. Agreed? I'm going to go to this point. So, let's say this would be -2, -4. If I move left 2, down 3. So, 2, 4, 6. So, 3 would be right here. Right? You guys with me? Okay, then I'm going to take this point. It says move left 2, down 3. Left 2, down 3. Left 2, down 3. Left 2, down 3. Cool? Now this is my answer. So I'm going to make sure that for me, so when I'm grading them, make sure that you have it darker, or that if you're doing with pencil, then erase the other one, okay? And voila. Please don't try to create a T-chart for this. It's going to take you forever. Okay? So let's summarize what we did. We found out all of our transformations. First, sketch yourself a graph just using the amplification and the period. Then, using the points that you have, just move left, right, up, down, whatever you had to do. And then that will be your answer. Questions? That's all I got for you today. Okay? Homework is on the calendar.